Hi students. In this lecture, I am going to discuss problems from IRODOV. Let us see first one. Let's see the question given. Two bars of masses M1 and M2 connected by a non-deformed light spring rest on a horizontal plane. The coefficient of friction between the bars and the surface is equal to mu. What minimum constant force has to be applied in the horizontal direction to the bar of mass M1 in order to shift the other bar? See here, main thing given, non-deformed light spring means no compression, no elongation for the spring. Okay. So we have to find minimum constant force has to be applied along horizontal to the bar of mass M1 to shift other bar. Let us see how to start. Let first make diagram for given data. So given two blocks, mass M2 connected by a non-deformed spring. That means spring is in its natural state. Means no compression, no elongation. It's mass M1. We have to apply constant force along horizon to move the other block. Okay. Now see how to start. If you want to move the other block, means M2, the spring force acting on that should balance frictional force on the block. Spring force, that is now right side. Suppose elongation is x, then spring force kx. When this block is about to move, then friction will be a limiting value. It is limiting value, which is equal to mu into M2G. Normal reaction M2G. If the spring force is able to balance limiting friction, then it is about to move. Okay. And question is that minimum force, minimum horizontal force that we have to provide. Say meaning of minimum. So when this is about to move, this block has to come to rest. Because if it comes to rest, then there will be no more elongation in the spring. Okay. For example, this block is still moving when this is about to move. And what happens is still it is moving, elongation keep on increases. Then spring force dominates limiting friction. Then block comes into motion. That's why when they ask minimum force, when this block is about to move, the other block should come to rest. Okay, let us see. So first condition, Kx should be equal to mu M2G. This is a condition one. So now we got a conclusion that when this block is about to move, the other block should come to rest temporarily. Okay, that means for this initially speed was 0, finally also speed 0. That means delta K is 0 for this block. That means we can take work energy theorem for this block. So I'm writing here work energy theorem for block M1. See how many forces are acting on this block. Applied force Elongation x means displacement is x. So because of the applied force, work done is F into x, which is positive. When this block is moving right side, frictional force, which is a kinetic, and that will be left side. Therefore, because of frictional force, work done minus mu mg into x. This is m1 next. Because of a spring force is left side. Elongation, it is left side. Displacement is right side. So by spring force also, work done is negative. So it is a minus half k x square. That is equal to 0. So we have taken work energy theorem for this block. So by applied force, work done, by frictional force, and by spring force, net work is equal to delta K. Now see calculation part from this. X and X remaining is F equal to, it is mu m1g plus kx by 2, and kx means mu m2g upon 2. This is now minimum force which we have to apply horizontally on M1 so that this block is about to move. Remember, this is not coming into motion. This is about to move. If we apply force slightly more than this value, then what happens is this block will come into motion. Okay, let us see next problem. See the question given. A chain of mass M and length L rests on a rough surface table so that one of its ends hangs over the edge. The chain starts sliding off the table. The chain starts sliding off the table all by itself, provided the overhanging part equals one third of a chain length. What will be the total work performed by the friction forces acting on the chain by the moment it slides completely off the table? Students, if you remember, almost same kind of question I have discussed from HC1. So in that mu value, directly mu given, in this we are supposed to calculate mu value. Okay, let us see how to start. So the basic condition here, the chain starts sliding off the table all by itself, provided the overhanging part equals one third of the chain length. So one third part is hanging. That is now key point to start the problem. So one third. So you can see here two third parties on the table and one third part is hanging. This is one third part. Now condition given that it is about to move of its own, and that happens if weight is able to balance, weight of the hanging part is able to balance the limiting friction between the remaining part of the chain and table. See here friction between the remaining part of the chain on the table. It is a mu into mass will be 2 by 3m. So mu mg. This is now limiting friction because chain is about to slide off its own, right? So it is now limiting friction. That is balanced by weight of the hanging part of the chain. that is m by 3 into g. Now from this we are going to get the value of mu. So m by 3g, m by 3g. So from this mu value is half. Okay. Now remaining part already we have done in HC Verma. Just remaining here at a distance x. Take element of length dx. Its mass will be m by L into dx. Its mass. Frictional force mu into its mass into g. Displacement is x. Between displacement and frictional force angle is 180. So we have to take here mass. Like this, we have to take all elements from x equal to 0 to x equal to 2L by 3. 0 to 2L by 3. That is work done by frictional force. So this is what we have done in that question, right? While discussing a HC Verma problem. Exactly same thing we have done. Minus, take constants outside, mu mg upon n, remaining x dx. It becomes x square by 2. X square 4L square by 9. Now in this, see cancellation n L and 2 here 2 times. It is minus and new value we got 1 by 2. So take 1 by 2 here and again 2 cancel minus m g L upon 9. Okay. That means the only difference in this problem and to that HC Verma problem, in that mu value given, here we are supposed to calculate mu. Okay, right. Let us see next one. Let's see the question. A body of mass m is thrown at an angle alpha to the horizontal with the initial velocity v0. Find the mean power developed by gravity over the whole time of motion of the body and the instantaneous power of gravity as a function of time. Okay, let us see once how to solve it. It is an oblique projectile. Oblique projectile. Velocity v naught and angle is alpha with a horizontal. Velocity v naught, angle is alpha with a horizontal. So taken vertically up as y-axis and a horizontal as x-axis. Now see power developed by gravitational force. Power that is equal to F bar dot V bar. Okay. So here gravitational force mg downwards. So mg into direction minus j cap. Because we have taken vertically up as positive y-axis. Okay. V bar. V bar will be, it is V naught cos alpha, which is a constant. So I cap plus it is V naught sine alpha minus gt j cap. Okay. And remaining just a calculation part. See the calculation part. I can take mg and mg can take outside. Okay. J cap dot I cap 0. So this part is not required. Remaining part j cap dot j cap, that is 1. Having here minus. Okay. Then see what we can do. Minus and take minus inside. Mg square mg square t minus mg v naught sine alpha. And you can see this is just like y equal to mx plus c. It is of that form. Means power due to gravitational force in case of an oblique projectile changes linearly with time, having positive slope and negative y-intercept. If you plot a graph, it is having positive slope and negative y-intercept. So graph will be graph will be graph will be like this. Okay. Slope positive, negative y-intercept. And this value is equal to this mg v naught sine alpha, right? And slope equal to mg square. This is a power, or you can say instantaneous power. Now in this we have to calculate what is the average power. What is the average power? And you can see average power. Since it is now changing linearly, we can write average power equal to initial power plus final power by 2. Okay. Let us now calculate what is initial power. Initial T0. So it is equal to minus mg v naught sine alpha, initial value. Now see what is the final power. Final power means when it is about to touch ground. About to touch ground means this is equal to time of flight. So substitute value in that mg square in the place of t. It is a 2v naught sine alpha upon g. This is time of flight minus mg v naught sine alpha. Now see what we get. Final value. 1g gets cancelled. 2mg v naught sin alpha minus mg v naught sin alpha. It is equal to mg v naught sin alpha. Initial value, final value, both are same values, but one is negative and one is positive. That means P initial plus P final, that is equal to 0. 0 by 2, it is again 0. That means average power during the entire time of flight is 0. Okay. So this is power and this is average power, right? Let us see next one. Let's see the question given. A particle of mass m moves along a circle of radius r with a normal acceleration varying with the time as n equal to at square, where a is a constant. Find the time dependence of the power developed by all the forces acting on the particle and the mean value of this power averaged over the first t seconds after the beginning of motion. Given circular motion and given normal acceleration, which is nothing but centripetal acceleration, that is at square. So we have to find power as a function of time and also average power. Let us see. So when you are taking circular motion, force is having two components. One is towards the center, known as centripetal force, and second one along a tangent. So centripetal force towards the center, centripetal force, and one is along a tangent, tangential force. And see the condition given, normal acceleration, or you can say centripetal acceleration. Both are same, that is equal to v square by r, which we are knowing, and that is given as at square. Okay. So if you want to find power, you can see centripetal force is always towards the center, right? And velocity is always along the tangent. So power is equal to F bar dot V bar. Centripetal force towards the center, velocity along a tangent. So between those two angles is 90. That means power delivered by centripetal force is 0. Okay. That means in circular motion, power delivered is only by tangential force. Okay. So to find power delivered by tangential force, we require tangential force m into a tangential. Okay. And from this we can say speed is keep on increasing. See here, v equal to root AR into T. Cross check once, v square equal to AR into T square. So v equal to root AR into T. From this we can say speed is keep on increasing. That means velocity and tangential acceleration both are in the same direction, or we can say tangential force and velocity both are in the same direction. That means the power delivered by tangential force in this problem is positive. So into velocity root AR into T. And what is A tangential? It is rate of change of a speed with respect to time. And that is how much? Root AR. Okay. Substitute values here. M AR into T. This is a power delivered by tangential force. And we have learned that power delivered by centripetal force is 0. That means the power delivered is nothing but power delivered by tangential force, which is equal to MAR into T. Okay, this is instantaneous power. Now we have to find average power in first T seconds. And you can see once again here, again you can see this power is not changing linearly with time. Therefore, average value is equal to initial value plus final value by 2. Initial value t equal to 0. So 0. Final value m a r t upon 2. That means average power is equal to m a r t by 2. Okay. So like this we can calculate. So here what we have to remember is in circular motion by centripetal force no power is delivered. Or if you remember, we have discussed that by centripetal force no work is done, because when we are taking small displacements, direction of a small displacement will be along the tangent. But centripetal force is towards the center, and between these two angles is always 90. So by centripetal force, no work is done. By centripetal force, there is no power delivered. It is only by tangential force. Okay. So I hope you got a clarity.